Welcome to this virtual reality tool to learn about quick clay landslide hazards. Make sure that you put on the head-mounted display appropriately and hold the hand controllers correctly. To start movement, use the joystick button on the left-hand controller. If you need to move forward on the virtual environment, push the joystick forward continuously. You have two alternatives to move inside the virtual environment. One is by continuously walking and the other is by jumping to a point. You can toggle these alternatives by pushing the joystick down vertically. To change directions or turn, use the joystick button on the right-hand controller. Push the joystick to left if you need to turn left in the virtual environment. Push it to right if you need to turn right. To select objects, use the trigger button on either of the controllers. Similarly, use the grip button on either of the controllers to grab and interact objects. Press the menu button on the left-hand controller. You can practice how to use these activities. If you want to continue to the main scene, click on the Continue option. Look at the wall in your right for pictorial description. Quick clay is the term used for a special type of clay which totally collapses and flows like a liquid when overloaded. Quick clay is found primarily in Norway and Sweden, but also exists in Finland, Russia, Canada, and Alaska. Quick clay is found below the marine level in Scandinavia. The marine level is the present elevation of where the sea level was at end of the last ice age. The Scandinavian peninsula, which includes Norway and Sweden, was covered with an ice layer of about 3,000 meters about 20,000 years ago. When the ice started to melt, the small clay particles flowed with the water and sedimented in the marine environment in salt water along the seashore. Even though the clay particles were originally deposited in salt water, they can be found near the current sea level or above due to the post-glacial uplift. Groundwater discharge has gradually reduced the ion concentration of the sediment's pore water. That is, the electrically charged particles have been washed out. These particles serve to stabilize the weak clay structure, and without them the clay becomes unstable. If such clay is overloaded, the clay structure, similar to a house of cards, will suddenly collapse. That is why it is denoted as quick. If the clay is exposed to sustained loading and subjected to remolding from natural causes or by man-made action, the clay masses will suddenly transform into a floating liquid in its own pore water. Click on the Continue button on the board to the left to return back the main menu. This is the first borehole. Click on the orange box to see the soil layers in cylindrical shape beneath the ground. Note that the soil layer dimensions are not in scale. The map on the right is the map of Gjerdrum municipality. Yerdrum is the second smallest municipality in Romerike with approximately 7,000 inhabitants. The municipality has an area of 83 square kilometer, of which approximately 25 square kilometer is agricultural area, 45 square kilometer forest, and 4 square kilometer is built up or transport area. The natural basis is characterized by clay soil areas below the marine border, and the forest in Romerike Mountains. Your relative location on the map is designated by the blue point on the map. You are south of Ask, the administrative center of the municipality. Much of the areas in the municipality are mapped for quick clay, which means the hazard and risk level of spots that are vulnerable to quick clay have been quantified. Hazard is an expression of the probability of a landslide, and it is evaluated by the topographical, geotechnical, and hydrological conditions and changes due to human activities, climate effects, and erosion. Based on these conditions, a hazard can be divided into 3 classes, namely high hazard, medium hazard, and low hazard. From topographic perspective, the criteria for hazard mapping are slopes with a height difference of 10 meters or a slope of more than 1 to 15. The assessment of ground conditions was usually based on very few boreholes. From this hazard map, the areas shaded by red, orange, and yellow strips represent high, medium, and low hazard areas respectively. You are now on a low hazard class. Hazard maps cannot always estimate the damage a quick clay landslide can induce. For example, a high-hazard landslide in uninhabitable mountain can be less dangerous than a low-hazard one in densely populated city. Hence, risk maps incorporate the hazard and the associated consequences. The consequences are based on population, settlement, infrastructure, etc. A risk can be categorized into 5 classes: Risk Class 1, Risk Class 2, Risk Class 3, Risk Class 4, and Risk Class 5. From this map, areas shaded from blue to red show risk classes from Risk Class 1 to Risk Class 5. The first 2 risk classes are within acceptable level of risk. The risk will result in no fatalities and only minor damages, hence, they do not pose a significant threat and can be ignored. Risk Class the third of may be acceptable over a short term. This risk will result in fewer fatalities and damages to structures, and it can be dealt with, especially with good planning, and do not necessarily require extensive resources. Risk Classes 4 and 5 are unacceptable and should be assigned high priority. The risk will result in many fatalities and damages to structures. Immediate risk reducing measures must be taken. You are now on a Risk Class 4 on the map. During quick clay hazard mapping, some ground investigation activities are required to confirm the existence of quick clay on a certain site. Ground investigation helps us to reveal ground conditions tens of meters beneath us. This map shows the locations of some boreholes bored in the vicinity of Ask, the administrative center of Yerdrum. You can visit some of them to see the results of geotechnical investigation results on site. Click on the Continue button on the board to the right to return to the main menu. This is the first borehole. Click on the orange box to see the soil layers in cylindrical shape beneath the ground. Note that the soil layer dimensions are not in scale. You can see the total sounding results along with the soil layers. You can grab the soil sample cylinders using the grab button on either of the controllers and move them to wherever you want. When you grab any soil layer, you will see the soil type. You can relate the total sounding chart with the soil layers. When you are done, click on the next borehole sign to go the next borehole. Click last borehole sign to go the last borehole, and back to return back to the main menu. Do the same until you reach the last borehole. This is the last borehole visit. Click on back sign to return back to where you start the visit.
QuickAware, det er miniblokk. Den er sånn ca. 5 minutter gammel. Hentet akkurat ca. 8 meter styrt på et tettsted utenfor Trondheim på billig. Den QuickAwaren er ganske fast, altså. Du kan sikkert sette en 20-30 kilo på den nede der uten at den tar noe vesentlig skade av det. Men den har jo for seg samme fasthet som ikke-QuickAware. Det er når vi begynner å trekke bort det her og røre om at det skjer det QuickAware. Det blir særdeles flytende når det blir omtrykt. Det var det våre. Her har rommet skjærstykket sånn kanskje rundt 0,2. Vi ser å gjøre det rundt, da. Det får tilført mer energi. Det vil bare av gårde. Her er en bit med kvikkleire. Så 10 taster. Det ganske fast og sprek. Og her det ikke så mye hold i. Og tilsette litt salt og få de bindingene til å komme tilbake på plass igjen. Det begynner å knytte seg. Den er ikke kvitt lenger.
Under marin grense, overalt der havet en gang har stått, kan vi finne kvikkleire. Kvikkleire er et sterkt materiale. Det er trygt å bo på kvikkleire så lenge den får ligge i ro. Kvikkleireskred kan utløses av 2 årsaker. 1. Anleggsarbeid. 2. Erosjon i bekker og elver. Anleggsarbeid kan utløse kvikkleireskred. Massene øker vekten på skråningen og kan utløse et lite skred. Skredet fjerner støtten som holder området med kvikkleire stabilt, som igjen utløser nye og større skred. Skredet vil fortsette til området med kvikkleire er tømt. Erosjon i bekker og elver kan utløse kvikkleireskred. Vannet i bekken spiser opp støtten som holder området med kvikkleire stabilt. Det kan utløse kvikkleireskred. Sannsynligheten for kvikkleireskred kan reduseres med ulike tiltak. 1. Bekken erosjonssikres slik at vannet ikke graver seg inn i massene. 2. Bekken erosjonssikres og bunnen heves slik at vannet ikke graver seg inn i massene. 3. Masse fjernes for å avlaste skråningen slik at skred ikke utløses. Disse tiltakene kan også kombineres. Det er strenge krav til bygging i kvikkleireområder. NVEs kvikkleireveileder beskriver dette. Les mer på nve.no/kvikkleire.
You are going to inspect the river against a potential erosion that can trigger a quick clay landslide. Start moving by pushing the joystick forward on the left controller. Look at any river morphology change and hover over on it to see any information about it. Follow the walkway until the end of the river. After the end of the river visit, follow the next walkway to go to the village to see if there is any human activity that can trigger quick clay landslide. At the end, follow the next instruction to go to the next scene. reported that a quick clay landslide has been already triggered in the village. Please go as far as possible from scraps of